Alright, good day class. My name is Pedro. Welcome to Better Faith e-learning platform. So today we're looking at trigonometry 1. And by next week look at trigonometry 2. So as far as SS1 is concerned, your first topic this term is trigonometry 1, nice third term. Alright, so under trigonometry 1, the subtopic there, the first one is the sine, cosine, and tangent of angles. The sine, cosine, and tangent of angles. So let's draw a right angle triangle to illustrate this. So this is a right angle triangle. This is a right angle triangle. So let's call here this side A, maybe this place B, and this other side C. So we want to see how we can get this trigonometric ratios, the sine, cosine, and the tangent. So this side is the opposite side. Let's call here theta. Anywhere this angle faces is the opposite side. So this place is the opposite. Then this side becomes the adjacent. Then of course, anywhere this right angle triangle is facing, this box right angle triangle 90 is called the hypotenuse. This is hypotenuse. So please take note. Alright, let's try to get this ratio sine, cosine, and tangent angle. So before now, you were told the acronyms that are used to determine sine, cosine, and tangent. We call it SOHCAHTOA. SOHCAHTOA. So use SOHCAHTOA. Of course, so let's go to this SO. First one is SO. What does SO represent? This S here stands for sines of angle. O means opposite, and the H there means hypotenuse. So this S, which is the sine, so sine, what is the angle there? Theta equals the opposite over the hypotenuse. What is the opposite here? Opposite is what? Then BC, that is the opposite, and our hypotenuse is length AC. So that is sine what? Theta. Then let's go to cos, which is CA. The C here represents cos. So cos theta, which is the theta here, equals the adjacent side is this one side, AB, over the hypotenuse, which is length what? AC. And then of course, we have the last one, TOA. The T here stands for tan, or tangent of angle. So the tan theta, this right angle triangle, equals our opposite is what? What is the side of opposite? Is BC. BC opposite. So BC over adjacent is what? Our AB. Hope you now understand. So please know very well that sine means opposite over what? Hypotenuse. Then cos means adjacent over what? Hypotenuse. Adjacent over hypotenuse. Then tan means opposite over what? Adjacent. If you like, you can write out the spelling in full, such as sine equals to opposite over hypotenuse, and so on and so forth. Alright, so we now take one example regarding this subtopic. So let's take one example. Calculate the angles of the triangle below. So this is the triangle. cm here, this side is 6 cm, and here is 8 cm. So this is the question. So I have to calculate the angles of the triangle below. What are the angles? We need just only two angles here. Angle B and angle what? Angle C. They're not given. So we already know that angle A is 90 degrees because of this right hand triangle here. So we calculate the side of what? Angle C and angle B. How do we get that? Remember, to calculate the side of any angle, you must use what? SOHCAHTOA. But if you are calculating the length of sides, we use Pythagoras what? Theorem. So how do we calculate the length of how do we calculate the angle of B and C? Now, since all the sides have been known, you can use sine, cos, or tan as this may be. So let's just use anyone. So let's call it theta. So sine theta equals opposite over hypotenuse from our definition. Opposite over what? Hypotenuse. The opposite over hypotenuse. What is our opposite here? Opposite means anywhere the angle is facing. If I place this theta here, this down part becomes my what? Opposite. So since theta is there, our opposite is what? 6. So which is 6 centimeter divided by what? What is our hypotenuse? Hypotenuse is what? Our length BC, which is 10 centimeter. Given to us. So please, this formula you have to memorize it: sine, cos, and tan. So by the time you cancel this, 6 over 10 will give you what? 0.6. So sine theta is 0.6. How do we get theta? Either you go to your 4-figure table or you use calculator to get the value of theta. Go to your 4-figure table, check the angle that has 0.6. That is the answer for what? Theta. The value for theta that is unknown. Or otherwise, use calculator to take the sine inverse of this very angle. So theta becomes the sine inverse, or you call it arc sine. The sine inverse of what? 0.6. So your calculator will give you the sine inverse of 0.6 and the answer will be there. So please, you have to be very, very careful if you are calculating this part, because some persons, once they get here, they don't know what to do again. So use calculator to calculate. So, like as I was saying, sine theta equals 0.6. How do we get theta? You take the sine inverse of this value you have here, or the arc sine. Go to the calculator, you press shift sine. This thing will be displayed. That is sine is 4 minus 1, sine inverse of this. Press shift, then press sine. This is sine 4 minus 1. So you now press 0.6 in front of it. You will get 36.86 something, just approximate it to 1 decimal place to give you 36.9 degree. So that is the value of what? Theta, which is this unknown angle. So reproducing the diagram ABC, that is triangle ABC, here of course is 90, 10 cm this side, 6 centimeter, and here is 8 centimeter. So this invisible angle is angle 90 degrees. If you don't know it now. The angle for B that's calculated for, that is theta, is what? 36.9. So we indicate it there. 36.9 degrees. Now how do we get angle C? Because they said in the question that we should calculate the angles of the triangle below, the angles of the triangle. We only know that yes, 90. We don't know the size of this angle C and angle B, of which we have gotten what? Angle B. That is theta to be 36.9. So now, let's look for the size of angle C. You don't need to use a sine, cos, or tan. Just use the normal principle that you know. The sum of angle in the triangle equals 180 degrees. Or just subtract 90. Subtract 36.9 from 90 degrees. You can get angle C. So whichever way you want to follow. So to get angle C, I don't want to waste my time. Just say angle C. This symbol means angle C equals 90 degrees minus 36.9. So by the time you subtract 36.9 from 90 degrees, your answer is 3.1 degrees. So that is the size of what? Angle C. So I believe this example, there is no problem with that. They only ask you to calculate the size of the angle, that's angle B and angle C. Angle B, I use theta to represent it. Then angle C, you also use alphabet. So I don't use any other symbol. So that's the size of the angle. So we have already known angle C, that is this very place, or this place, to be what? 53.1. By the time you add all the angles within this triangle, 90 plus 53.1 degree plus 36.9 it will give you 180 degrees. That is the sum of angle in a what? Triangle. So let's quickly go straight to example 2. Example 1. We are through with example 1. Let's look at example 2. So example 2, a triangle has sides 8 cm and 5 cm and an angle of 90 degrees between them, and an angle of 90 degrees between them, and an angle of 90 degrees between them. Calculate the smallest angle of the triangle. Calculate the smallest angle of triangle. Alright, so let's solve this question. This is basically a WAEC question. So if you're not careful enough, you will make a mistake if you are solving it. So a triangle has sides 8 cm and 5 cm and an angle 90 degrees between them. So between these two sides, we have an angle 90 degrees between them. Use your common sense, your imagination. So just assume that we have, since it's angle 90 degrees, it means a right angle triangle is going to be formed, which is 90. So this place is what? A 90 degree. You don't even need to show the 90 degree out. This box, anybody that sees it know that it's what? 90 degrees. So I can choose to clean, erase this 90 off from the question. Then between them we have the side, we have 5 centimeter and 8 what? Centimeter. So sketch it like this, you don't have any problem. Alright, you can call here what? Theta. So a triangle has side what? 8 cm and 5 cm and an angle of 90 degrees. This is 90 degrees between what? Between them. So 90 degrees between these two. Alright. So having said that, it says you calculate the smallest angle of the what? Triangle. What is the smallest angle we are looking for? Is what? It is theta. I'm looking for a value of what? Theta. Calculate the smallest angle of triangle. So this is theta. Somebody said, can't you quickly locate theta here? So okay, if you put theta here, this place becomes opposite, while here becomes what? Your adjacent. So then you have to change the parameters. Here will be 8, here will be 5. Alright, so what we now do? Following your trigonometric ratio, this place theta is facing this side, here it becomes opposite. Okay, with me, students. So here is opposite, here is what? The adjacent. So opposite, here is opposite, and this side is what? The adjacent. So opposite, adjacent. Which ratio should we use? Out of SOC at 12, it is 12 because the 12 there has the opposite and the adjacent. So you now say tan, since it is 12 now, this is tan. So tan theta equals opposite over what? Over adjacent. Having said that, you now continue. Now say tan. What's our theta there? We don't know. That's what I'm looking for. The smallest angle equals the opposite view to us there is what? 5 centimeter over what's our adjacent? 8 centimeter. So please do not forget this rule. By the time you cancel out cm and cm, divide 8 and 5. So now say 8 divided by what? 5. 8 over 5. You have 0. Tan theta, you have 0.625. So likewise what you did here, you take the tan inverse. Your calculator, you press to get the angle theta, you press shift, then tan of this one here, 0.625. So theta becomes shift tan, you see tan inverse there 0.625. Your answer will be 32.00 degree. I stage 2 what? Degree. 2 in the other degree. So please, this question is very, very what? Simple. Very, very simple. So the angle, or rather the smallest angle of the triangle is 32 what? Degree. You now see, therefore, the smallest angle of the triangle is 32 what? Degree. So that is the answer. Hope you are with me. So, having said that, the next subtopic that we're looking at is complementary angles. Let's start complementary what? Angles. Complementary angles. Complementary angles. Complementary angles. What are complementary angles? Two angles are said to be complementary if their sum gives 90 degrees. For instance, this is a right angle triangle. Let's call here theta. If you are following me, this theta here is 90 degrees. Let's call here A, B, and this side is side C. So this angle here is 90 what? Degree. Now let's see the angles that are complementary to each other. Alright, so we don't know angle B. I solved the question before now. That was in example 1. If you have been given this place to be 90, of course 90 degrees, anywhere the vertical and horizontal line intersect, when you get what? Angle 90 degrees, right angle triangle. So here is what? Your theta. So how do you get this angle B? To get angle B, just simply say 90 minus what? Theta. So to get the size of angle B, the size of angle B becomes what? 90 degrees minus what? Theta. Or you can call here S. This unknown angle, just say S. That's S plus 90 plus theta equal to 180. By the time you collect like terms to get rid of S, arrive at what? This. Alright, so this very place now is now 90 degree minus theta. What are the angles that are complementary there? The complementary angles here are angle A and angle B. That is, if you sum up angle A and angle B, you're going to get 90 degrees. They are complementary angles. So angle A plus angle B will give you what? 90 degrees. What's angle B? Angle A is theta plus angle B is what? 90 degrees minus theta. If you are following me. So rearrange, you have theta minus theta plus 90 degrees. Theta cancel theta, don't have what? 90 degrees. So angle A plus angle B will give us what? 90 degrees. They are complementary angles. Alright, so let's take two examples on complementary angles. Two examples on complementary angles. So looking at this triangle ABC on the board, anywhere this capital letter, that is the bigger angle A faces, we have the smaller side there. So this is the opposite side. So here is the smaller side. This is the bigger angle. So we have this side, smaller side. Then the bigger angle will be the opposite side is what? Now, so you can also get your sine, cos, and tan. We want to derive the formula for solving complementary angles. Alright, so sine theta, for instance, theta is sine is equal to hypotenuse. What is opposite there? We have A. What is hypotenuse there? It's smaller than what? C. I don't want to be using BC over AB. Let's just use the alphabet that I used to represent the side. So A over C. Now, cos theta equals, what is cos? Adjacent over what? Hypotenuse. Adjacent is what? B. And hypotenuse is what? Is C. Then of course, tan theta equals opposite of adjacent. Opposite is what? Is A. Adjacent is B. Now let us see. Want to compare this angle here, this theta, to this very angle. Now I have used angle theta to get sine, cos, and tan. Let's go to this angle here, this 90 minus theta. If I'm considering this angle here, this 90 minus theta, I want to compare these two angles. If I should consider this place, it means anywhere this angle is facing becomes opposite side. So since I'm considering 90 minus theta, here is opposite angle, here becomes my adjacent, and here is what? The hypotenuse. Why? Because I'm considering 90 minus what? Theta. I have considered this one before. Alright. So sine theta equals A over C when I consider theta opposite over hypotenuse. So let me see the position where this A over C is located if I'm to consider this angle in question. So A over C, if I consider this place, here is the opposite. The A there is adjacent and the C is hypotenuse. So it's written as cos bracket what? 90 minus theta, because adjacent over hypotenuse is what? Is cos. That means the position of A and C, they are what? They are cosine. Alright, so let's look at this one. B over C when I consider theta. Cos theta is adjacent over what? Over hypotenuse. Now I want to consider this angle. If I should consider here is opposite, of course, I've said it before. The here is adjacent, the here is hypotenuse. Let us see the position of this B over C when this one is being considered. If I should consider here, B becomes opposite and C becomes the hypotenuse. B is opposite and C is the hypotenuse if this one is being considered. So opposite over hypotenuse is sine. Now say sine bracket what? 90 degree minus theta. Then lastly, if I should consider tan theta, which is this opposite over adjacent. The tan of this very one, the tan is our A over B. This one is A. A is adjacent and B is opposite. It's like the inverse of tan. If I should consider this one, is the inverse of tan or the reciprocal of tan. By the time you get to SS2, they teach you inverse of tan, inverse of cos. Inverse of tan theta. Inverse means 1 over, what's our theta? A over B. By the time you solve mathematics, you will get B over A. So we are having something like B over what? Over A. We have B over what? A. So tan means opposite over what? Adjacent. Here is opposite. Here is what? The adjacent. When I consider theta. If I consider this angle here, my opposite will be B. My adjacent will be A. It's like inverse of this one. So inverse of tan gives cot. Now see cot bracket 90 degree minus theta. So let's quickly take one of the examples on complementary angles. On complementary what? Angles. Alright. So let's take just one example on complementary angles. So first of all, we will just focus on the sine and the cosine of complementary angle. So by the time you bring these two together, you have sine theta is equals cos bracket 90 degree minus theta, and then of course cos theta equals sine bracket 90 degree minus theta. So I'm going to work with these two formula to solve complementary angles. So these two formula, please take note of them. Alright. So the first question is solve the following. It means we are calculating for the value of what? The unknown, which is theta. So quickly write sine 3 theta equals cos 4 what? Theta. Now, you are going to compare this to any of this formula. If you want to use sine, use sine. If you want to use cos theta, use cos theta. So it depends on you. So let's just take sine theta equals cos bracket 90 degree minus theta. So let's watch. Now, comparing this to this, I want to compare both of them. So now say sine theta, and theta here is what? 3 theta equals, I want to make both of the both sides of the sine or cos, that's how we do comparison. Whether the both sides are sine or what? Cos, I can eliminate them. So sine 3 theta, which is this one, equals, instead of putting cos here, I will now bring in sine. Why? Because I want to eliminate sign. I want to cancel out sign. So now the sign bracket 90 degree minus the theta here becomes what's attached to what? The cos, that is 4 theta. I come again. Sine theta, the theta we have in front of sine here is 3 theta equals, I said was the sine or cos. Now say equals sine bracket 90 minus this theta here is whichever value you have in front of cos, that is 4 theta. So here you put what? Your 4 theta. At the end of the day, you cancel out sine, cancel sine. 3 theta equals 90 degree minus what? 4 theta. So at this stage, you quickly what? Collect like terms. So if you collect like terms here, becomes you have 3 theta plus 4 theta equals 90 what? Degree. This minus 4 goes this way. So here, add up, we have 7 theta equal to 90 degree. Use your calculator, divide this by 7. 7 theta over 7 equal 90 over 7. 7 cancel 7. So divide 90 by 5, 12.85 degrees. Or you can calculate one decimal place, 12.9 degrees. So that is all for question A. Then lastly, question B, following the same order. Question B, following the same order to solve it. I told you can use cos bracket theta plus 10 degree equals sine theta. Use any formula. Okay, let's use cos. Cos theta equals sine bracket 90 degree minus theta. This formula came from the complementary triangle. I told you that I'm going to use 2 formula. Are you getting it? Either here will be sine or here will be what? Cos. So compare this formula to this very one. Now, I want to make both side cos so that I can cancel it. First I use sine. So here becomes cos bracket. This theta, what is in front of cos here? Is theta plus 10 degree. So this theta here means theta plus 10 degree equals this other side, double sine. You must put what? Cos, so that you can eliminate, cancel out at the end of the day. Cos bracket 90 degree minus this theta. What is attached to sine here is same thing as theta. Assuming I add 5 theta, I would have written 5 theta. Since theta and theta, I think just put another word there, theta. Are you getting me? So cos cancel cos becomes theta plus 10 degree equals 90 degree minus what? Theta. Collect like terms. Now theta goes this way, becomes plus theta equals 90 minus 10 degree. Now theta plus theta gives you 2 theta. So 2 theta equals, subtract 10 from 90, we have 80 degrees. So that is by 2. You get your theta over 2. This cancel this. So theta equal to what? 40 degrees. So that's the value of theta. So please, I don't know if you after getting your theta, try to substitute back into the equation. If you put theta here 40 plus 10 give you 50. The here is 40. So cos 50 and sin 40, they are the same thing. That's how to check if your answer is correct. So please go and practice exercise 15.1 number 1 to 5. Practice exercise 15.1 number 1 to 5. Thank you very much, class. See you next week, Monday.